In July 2025, telescopes in Chile detected something that shouldn't exist. An object from deep space with a tail pointing directly at the sun. This defies everything we know about physics. But this is only the first of several impossibilities. Because when scientists analyzed its trajectory, they discovered it hadn't arrived here by chance. Its path was too precise, too deliberate. And now it was hiding behind the sun, in a region no telescope could see. This is 3I/Atlas, the third interstellar visitor ever recorded. And unlike anything that came before, it's forcing the scientific community to consider a possibility that no one wants to admit publicly. What you're about to discover goes beyond scientific anomalies. We'll dive behind the scenes of a discovery that has divided astronomers worldwide, analyze data that challenges our understanding of the cosmos, and reveal why some of the biggest names in astrophysics are whispering about artificial propulsion. It all began with a point of light lost among millions of others. A routine scan by the Atlas Observatory in Chile, designed to hunt for near-Earth dangerous asteroids. It was the first week of July when detection algorithms flagged something unusual. It wasn't just another space rock. Its speed was completely off the charts, over 200,000 kilometers per hour, slicing through space in a straight line. Numbers that only make sense for objects coming from other stars. But interstellar speed, while rare, isn't impossible. We'd seen it before with Oumuamua in 2017 and Borisov in 2019. What made this third visitor special was what happened when astronomers around the world pointed their telescopes at it. The first images came from the Gemini South Telescope, then from Lowell Observatory in Arizona. Each new photo confirmed the impossible, a bright, persistent comet-like tail, but pointing in the wrong direction. In over 4 centuries of astronomical observation, nothing like this had ever been documented. Comet tails always point away from the sun, pushed by solar radiation pressure. It's a fundamental law of physics, as basic as gravity. 3I/Atlas broke that rule. Dr. Bryce Bolin, a veteran in cometary science, described the discovery as challenging all known paradigms. Other researchers were more direct: this simply shouldn't be happening. And it wasn't just the direction of the tail. Its consistency defied explanations. For days, it maintained the same shape, the same intensity, pointing directly at the sun like a focused jet. It didn't wobble, disperse, or follow the chaotic patterns typical of ice sublimation. It seemed controlled. NASA's JPL teams ran computational simulations, trying to replicate the phenomenon. They tested different ice compositions, varied rotation speeds, adjusted radiation pressure models. Nothing worked. All natural scenarios failed to explain 3I/Atlas's directed plume. Then the James Webb Space Telescope stepped in. Its spectroscopic analysis revealed a chemical composition that broke yet another astronomical rule. The ratio of carbon dioxide to water was 8:1, a staggering value that defies everything we know about comet formation. In the vast majority of catalogued comets, water dominates completely. Carbon dioxide appears only in small amounts. Even in the most extreme cases, ratios rarely exceed 4:1. But 3I/Atlas arrived with 8:1, a chemical signature that doesn't fit any planetary formation model in our solar system. Even more intriguing was the detection of atomic nickel in massive amounts, over a trillion atoms ejected per second. But iron, which normally accompanies nickel in celestial bodies, was absent. An anomaly suggesting formation conditions radically different from anything found here. These data pointed to an exotic origin, a stellar system so unlike our own that it produced an object with impossible chemistry. But the strange origin still didn't explain the strange behavior. Because as weeks passed, astronomers began noticing something even more unsettling. 3I/Atlas wasn't just behaving anomalously, it was subtly, yet measurably, accelerating, always toward the sun. Precision astrometric measurements revealed tiny deviations in its trajectory. Minuscule, but consistent. As if a constant force were being applied, gently pushing it toward our sun. The magnitude of the acceleration was extraordinarily small, equivalent to the weight of a feather landing on your hand. But in the vacuum of space, even the tiniest force accumulates over time. And the direction of that acceleration was perfectly aligned with the impossible tail. It was as if the plume wasn't just a bizarre visual phenomenon, but evidence of something actively propelling the object. And this led some scientists to a conclusion few dared to voice publicly. Dr. Avi Loeb, Harvard astrophysicist known for his controversial theories, was the first to say the unthinkable. The plume of 3I/Atlas looked remarkably like the exhaust of an ion engine, the same technology NASA uses to propel probes through deep space. Ion engines don't explode dramatically like chemical rockets. They use electric fields to accelerate charged particles, creating a smooth, constant thrust through a focused, persistent jet. Exactly the type of signature 3I/Atlas was exhibiting. The suggestion sent shockwaves through the astronomical community. Some colleagues dismissed it as premature speculation. Others began reviewing their own data with more critical eyes. But regardless of opinions on artificial propulsion, one fact remained indisputable. 3I/Atlas was challenging our fundamental understanding of how celestial objects behave. And there was yet another mystery unfolding, something that made the situation even more unsettling. This other mystery was hidden in the numbers. When astronomers mapped the full trajectory of 3I/Atlas, they discovered something that made even the most hardened skeptics pause. It hadn't arrived in our solar system by chance. Typical interstellar objects behave like cosmic stray bullets. They arrive at random angles, travel through space chaotically, with no regard for where planets or their orbits are. It's pure statistics. The universe is vast, and the odds of alignment are practically zero. 3I/Atlas broke that rule too. Its orbit was inclined just 5 degrees relative to the plane where Earth, Mars, and Venus orbit the Sun. To put that in perspective, imagine throwing a coin from another galaxy and having it land perfectly aligned with a specific table here on Earth. The odds are roughly 2 in 1,000. But the precision didn't stop there. Orbital simulations revealed that 3I/Atlas would pass near 3 planets in almost perfect sequence: Mars in October, Venus in November, and a distant encounter with Jupiter in March. Not close enough to pose any danger, but far too precise to be coincidence. Dr. Sarah Martinez, an orbital dynamics specialist at JPL, ran the calculations multiple times. Each simulation confirmed the impossible. The odds of an interstellar visitor passing near 3 inner planets in sequence were less than 1 in 20,000. It's as if someone planned a sightseeing tour of the inner solar system, she remarked during an internal meeting that later leaked to the scientific press. This orbital precision echoed something the astronomical community preferred to forget. In 2017, another interstellar visitor had caused a similar stir. Oumuamua arrived as a giant rotating stick, with no visible tail, no detectable gas emission. At first glance, it seemed like an ordinary asteroid, until orbital data revealed an inexplicable acceleration that defied the laws of gravity. The object was gently accelerating as it moved away from the Sun. Not much, but enough to be measured precisely. And no one could explain why. The scientific community split into factions. Some proposed that Oumuamua was a sublimating hydrogen iceberg. Others suggested solid hydrogen fragments or exotic geometries creating anomalous radiation pressure. But Dr. Avi Loeb of Harvard University offered an explanation that made global headlines. Oumuamua could be artificial. A solar sail sent by a distant civilization, pushed along by stellar radiation pressure. The proposal generated equal parts scientific outrage and public fascination. Loeb's colleagues accused him of sensationalism. He responded with data. No natural model could fully explain Oumuamua's behavior. The debate dragged on for years, dividing the community between exotic natural explanations and the unthinkable possibility of an artificial origin. Then, in 2019, 2I/Borisov arrived. This third visitor behaved exactly as a comet should. Tail correctly aligned, standard chemical composition, predictable trajectory. Borisov restored a sense of normalcy. Interstellar objects could be strange, but they still obeyed the laws of physics. That sense lasted until July 2025. 3I/Atlas reopened all the questions Borisov had silenced. It had a comet-like tail, but pointing the wrong way. It released gases as expected, but in the wrong composition. And it accelerated measurably, but always toward the Sun. It was as if someone had taken the lessons learned from Oumuamua and created a more sophisticated version. But there were crucial differences. Where Oumuamua accelerated away from the Sun, 3I/Atlas accelerated toward it. Where Oumuamua showed no visible activity, 3I/Atlas displayed a bright, persistent plume. And where Oumuamua sparked debates about passive solar sails, 3I/Atlas seemed to exhibit active propulsion. Dr. Loeb was quick to point out the similarities with human technology. The plume of 3I/Atlas was remarkably similar to ion engine exhaust, not just in appearance, but in behavior. Ion engines produce thrust by expelling charged particles through electric fields. The result is a narrow, focused jet that can operate continuously for months. Exactly the type of signature 3I/Atlas was producing. Even more intriguing was the timing. If you were a probe arriving from interstellar space and needed to decelerate, the most efficient method would be to use the Oberth effect, burn fuel at the point of closest approach to a gravitational source to maximize efficiency. This would require orienting the engines toward the Sun during perihelion, exactly the configuration 3I/Atlas was displaying. Critics argued that exotic ice compositions or unusual rotation geometries could explain the phenomenon. Perhaps regions with supervolatiles were erupting in a directed way. Perhaps the object was spinning in just the right orientation to create an optical illusion. But attempt after attempt to model these explanations failed. No natural scenario could simultaneously reproduce the direction, intensity, persistence, and focus of 3I/Atlas's plume. As the scientific debate heated up, the object itself continued its inexorable journey toward the Sun. And as it approached, astronomers began to notice something that made the mystery even more frustrating. 3I/Atlas was heading for the one place in the solar system where it would be impossible to observe. In astronomy, there is a phenomenon known as solar conjunction, when an object passes behind the Sun from Earth's point of view. During this period, the Sun's brightness makes any observation impossible. No optical telescope can see through it. No radar can penetrate the interference. It's a complete cosmic blind spot. And 3I/Atlas was heading straight for it. Orbital projections indicated that on October 30, 2025, the object would pass perihelion, its closest approach to the Sun, completely hidden behind our star. It would remain invisible for weeks. From an astronomical observation standpoint, it was the most frustrating timing possible. From the standpoint of a hypothetical alien probe, it was perfect. If something wanted to perform maneuvers undetected, execute dramatic course changes, or even completely alter its trajectory, this would be the ideal moment. Hidden behind the most powerful energy source in the solar system, with access to extreme conditions that could mask any activity. Space mission engineers know well the strategic value of solar conjunction. It's when human probes often perform their most critical burns, using the Oberth effect to maximize fuel efficiency. If 3I/Atlas were truly under some kind of control, natural or artificial, this would be the moment to act. Teams from NASA and the ESA had already scheduled intensive observation campaigns for when the object would re-emerge on the far side of the Sun. Telescopes around the world would be ready to capture any changes in its position, brightness, or trajectory. But until that moment arrived, 3I/Atlas would remain a mystery sealed behind the brightest light in the solar system. And when it finally reappeared, the numbers would reveal whether we were dealing with the strangest scientific anomaly ever recorded, or with something entirely different. At this very moment, as you watch this video, 3I/Atlas remains hidden behind the Sun. Silent, invisible, and possibly in motion. Telescopes around the world wait for its reappearance like detectives awaiting a suspect to step out of hiding. When it finally emerges from the other side of our star, every pixel of change will be analyzed, every orbital deviation measured with obsessive precision. If 3I/Atlas reappears exactly where it should be, following the same gravitational laws as always, we may be able to file this case as yet another fascinating scientific anomaly. An exotic chemical composition from a distant stellar system, behaving oddly for reasons we do not yet understand. But what if it doesn't reappear where it should? What if its speed has changed? What if its trajectory has altered in a way impossible to explain by solar gravity alone? What if the focused plume that defied all natural explanations intensified during its time hidden? These are not purely academic questions. They strike at the core of our place in the cosmos. For centuries, we have operated under the comfortable assumption that we are unique, or at least rare enough that visitors from other worlds are statistically impossible. Oumuamua shook that certainty. 3I/Atlas shattered it completely. Because even if we completely dismiss the possibility of an artificial origin, what 3I/Atlas represents is equally unsettling. Our fundamental understanding of how the universe works may be incomplete. Objects shouldn't behave this way. Tails shouldn't point toward stars. Interstellar trajectories shouldn't be so precise. Chemical compositions shouldn't be so exotic. If 3I/Atlas is natural, then nature is stranger than we imagined. If it is artificial, then we are not alone. Both possibilities are revolutionary. Dr. Avi Loeb, despite all the controversy his theories have generated, made an observation that resonates beyond academic debate. The question is not whether we should consider extraordinary explanations. The question is whether we can afford not to consider them. And perhaps that is the deepest lesson of 3I/Atlas. Not that aliens have definitively visited us, but that our scientific arrogance may be blinding us to possibilities that deserve serious investigation. The astronomical community is already preparing for the next step. Robotic missions are being proposed to intercept the next interstellar visitor before it escapes into deep space. New detection algorithms are being developed to identify anomalous objects more quickly. And protocols are being established in case we discover something that challenges not only our understanding of physics, but our understanding of our place in the universe. 3I/Atlas forced us to confront an uncomfortable truth. The cosmos is full of phenomena we do not understand, coming from places we have never visited, operating by rules we have never encountered. When it re-emerges from the other side of the sun in the coming weeks, we will have our answer. But regardless of what the data reveals, one thing has changed forever. We now look at the night sky differently, knowing that among billions of distant stars, something may be looking back. And that the next time we detect a point of light moving where it shouldn't, we may not want to assume automatically that we understand what we are seeing. The universe has just reminded us that it still keeps secrets, and some of them may be closer than we would like to admit.